In section 2.5, you will write and graph direct variation equations. Two variables x and y vary directly if y equals ax for some constant of variation a. So if y equals ax, then that constant of variation a is just y divided by x. In our first example, we're going to write and graph a direct variation equation that has -3, -9 as a solution. So since this equation is direct variation, we know it's of the form y equals ax and to write the equation, we just need to find that constant a. So a is equal to y over x for any point in this direct variation, and they give us a point, -3, -9, so we can substitute in -9 for y and -3 for x and simplify, getting 3. So we find out that our constant of variation is 3, and now we can write our equation, y equals 3x. Now we want to graph this direct variation equation, and we can see that this equation is just in slope-intercept form, y equals mx plus b. A, our constant of variation, is nothing more than our slope, and our y-intercept b is always 0. So when we graph this equation, we know it's going to cross the y-axis at 0. That's our y-intercept. And then our slope is 3, so from there we can go up 3 and over 1 to graph more points on this line. We could also graph the point that's given, -3, -9, and then draw our line through those points. So this is the direct variation equation and graph, y equals 3x. Hooke's law states that the distance d a spring stretches varies directly with the force F that is applied to it. Suppose a spring stretches 15 inches when a force of 9 pounds is applied. Write an equation that relates d to F. Use the equation to predict the distance that the spring will stretch when a force of 6 pounds is applied. So we're writing a direct variation equation. So we know that that form is y equals ax. Only our variables are not y and x, our variables are d and f. D varies directly with f. So to write this equation in d and f, we still need to find that constant of variation a. And to do that, we want to use the values that they give us. They say that when the spring stretches 15 inches, so in for d we can substitute 15, a force of 9 pounds is applied. So we'll substitute that in for f and simplify by getting rid of a factor of 3 top and bottom. So our constant of variation simplifies to 5/3. And now that we know a is equal to 5/3, we can write our equation by substituting in 5/3 for a. So here's our equation that relates d to f. And now there's another part to this problem. The first part is to write the equation, and the second part is to use the equation. So now we'll use our equation, d equals 5/3 f. Because now the force changes to 6 pounds, and we want to find the distance that the spring will stretch. So we'll substitute in 6 for f and simplify on the right here, multiply. And when we multiply these fractions, we can cancel that factor of 3 top and bottom. So we're left with 5 times 2, or 10. So we know that when 6 pounds of force is applied, that spring will stretch 10 inches. In direct variation, the variables vary directly or the same. As one variable increases, the other variable increases. If that variable decreases, the other variable decreases. So in this problem, the force went down from 9 pounds to 6 pounds. We would expect the stretch to go down also, and it did, from 15 inches to 10 inches. So the variables are varying directly or the same in direct variation. Does the data show direct variation? If yes, write an equation relating x and y. So we want to look at this table of values and decide if there is a constant of variation for every ordered pair. Does a equal y over x for every ordered pair? So does 2.4 divided by 8 equal 4.8 divided by 16? Equal 7.2 divided by 24? Equal 9.6 divided by 32? And finally, 12 divided by 40. And you can see that in each case that ratio does simplify to 0.3. We do have a constant of variation, so we can say yes, this data does represent direct variation, and when we write our equation, our direct variation equation, we know that that constant of variation is 0.3, so we can substitute it in for A, and here's our direct variation equation that relates x and y for this data. That constant of variation 0.3 is nothing more than a slope or a rate of change, and that rate of change is representing price per ounce. So we can see that the price for 1 ounce of nuts is going to be 30 cents. The dimensions of 5 rectangles, each with an area of 24 square feet, are given in this chart. Tell whether length and width show direct variation. If so, write an equation that relates the quantities. So again, we'll look for a constant of variation by dividing every ordered pair. Does 24 divided by 1 equal 12 divided by 2? And right here we can see that it doesn't. 24 divided by 1 is 24, and 12 divided by 2 is 6. So they are not equal, so all we have to say is that no, this data does not represent direct variation, and there's no equation to write. Include in your notes of this video guided practice problems 2, 4, and 6 found on pages 107 and 109 of your textbook.